Microphone on? Crap. My microphone is on. I got juked. Let's go. Okay, cool. Okay, similarity practice 2. We've got this question. I'm going to start moving faster, so hopefully this website that I'm on, or app that I'm on, will let me post one video because it has to be less than 10 minutes. It's crazy, but anyway, we're going to start moving a little bit faster now because you understand how, like, the basics of similarity, hopefully. So let's talk about it. We are given 4 similar triangles. 4 similar... Oh god, that is huge. Let's go down. 4 similar triangles. Areas 1 squared, 3 squared, 5 squared, and 7 squared. The smallest triangle has a perimeter of 4. Find the sum of the triangle's perimeters. Alright, first thing I'm going to briefly go over. Before we talked about how height and base are related to make this proportionality thing, which leads to this. And, oh crap, that should be over there. That extends to perimeter. And the reason that is because perimeter is comprised of H and B. So as H increases, B also has to increase. So they're both going to increase, which means that if H is proportional to B, then H equals BC. So you'll get something like B plus BC, which means this is going to be increasing at a factor of B squared, and especially when you divide these. Actually, that doesn't really... Oh, yeah, no, this works, okay. Wait, does it? Crap. Is this a faulty explanation over P1, P2 equals... Yeah, that was a faulty explanation. It's going to look like this. You're going to factor out 1 plus C on both of them, because C stays the same, and obviously 1 does as well. You get, you end up getting P is proportional to B1, and because B squared is proportional to A, you're also going to get P squared is proportional to A. So hopefully that makes sense. I'm sorry for the slight mislead for a second, but this is what it'll end up looking like. Yeah, the fact that there's an H and a B does not really matter. It's just the fact that it's comprised of H and B, as I just showed. So area is proportional to P squared, meaning you can also make an area 1 over area 2 equals P squared 1 over P squared 2. Now, we know that because the smallest triangle has an area of 1 squared, and the smallest triangle also has a perimeter of 4, we know that our first equation will be... I'm actually going to first rearrange this to A1 over P1 squared equals A2 over P2 squared. I think it might be easier to follow. So our area 1 is that 1 squared over 4. Oh god, that does not point the right direction. Anyway, over 4. And what I want you to notice is the fact that 4 is actually 2 squared, which makes it nice. Oh wait, crap, no, that's not... Well, it's true, but because P1 is squared, you already get a square here, so there's no reason to go any further. We are looking for... Well, we know that area 2 is 3 squared, and we are looking for P2 squared. Now you solve for P2 squared, 2 squared, and you'll see that because everything is in terms of squares, you actually get a nice thing. When you square root, you get P2 equals 3 times 4, which is 12. Now you got that the perimeter of that is equal to 12. Now you'll actually see that there's a pretty nice pattern that follows. I'm going to switch the equation to this, just, that's not how it works, algebraic manipulation to make it a little bit easier. because we are always going to be looking for P2. We're going to go back to using our area 1 equaling 1 squared and P1 equaling 4. So you get 4 squared over 1 equals, we are looking for P2 squared again, but now we're going to use area of 5 squared. 5 squared. Oh, crap. Then you get 4 squared times 5 squared equals P2 squared, and 4 times 5 equals P2. And the last step is literally just finding this 7 squared. And you're going to get the same exact process. By the way, this equals 20. You're going to get the same exact process. 4 squared over 1 equals P2 squared. Obviously, all these P2s are different. I'm just using them for simplicity. But all these P2s are different. 7 squared, and you end up with 4 times 7, because the square root equals, what's that equal? 28, which equals P2. Obviously, I should have used different P's for each of them, but moral of the story, your 4 values are, the first one was, 4, the first one's 4, the second one's 12, the third one is 20, and the fourth one is 28. So you get 4 plus, 12, plus 20 plus 28. To quickly solve this, I like to do it like this. 12 goes into 28 to make 40. This goes here, 24. 40 plus 24 is 64, so that is the answer. Hope that made sense. I hope this part specifically made sense. The rest of it is pretty simple once you get the pattern down, and if you can see this immediately, then the pattern will come pretty fast. So, hope that helped. Yeah. Go there. Stop recording. Stop.